At its narrowest point, the Strait of Gibraltar, separating Europe and Africa, spans a mere 14 kilometers, or about 8.7 miles. This seemingly close distance might appear ideal for a bridge connecting two continents. However, the reality is far more complex. The geographic intricacies of the strait present formidable challenges to such an ambitious engineering feat. The strait's seabed is far from a flat, stable platform. Deep canyons and shifting underwater currents make anchoring a bridge an incredibly difficult task. Imagine attempting to build a bridge on a constantly moving foundation, and you begin to grasp the magnitude of the challenge. Furthermore, the coastlines of Spain and Morocco, while close at the strait's narrowest point, diverge significantly on either side. This divergence would necessitate an incredibly long bridge, spanning not just the strait itself, but also a considerable portion of the surrounding landmasses. The geographic realities of the Strait of Gibraltar, while seemingly surmountable at first glance, present significant hurdles for bridge construction. The combination of deep canyons, unpredictable currents, and diverging coastlines creates a challenging environment for such a monumental project. Beneath the surface of the Strait of Gibraltar lies a complex and dynamic underwater environment. The strait serves as a gateway between the Atlantic Ocean and the Mediterranean Sea, resulting in strong currents that flow in both directions. These currents are not merely powerful, but also subject to constant change, influenced by tides, winds, and the differing densities of Atlantic and Mediterranean waters. The depth of the strait further complicates matters. The seabed plunges to depths exceeding 900 meters, almost 3,000 feet in certain areas. Constructing bridge supports at such depths would be a monumental engineering undertaking, requiring innovative techniques and materials capable of withstanding immense pressure. Imagine attempting to build a skyscraper underwater, constantly buffeted by strong, unpredictable currents. That's the challenge posed by the strait's depths and currents. These factors, combined with the seabed's uneven terrain, create a formidable obstacle for bridge construction. The dynamic nature of the strait's underwater environment makes it an exceptionally challenging location for such an endeavor. The Strait of Gibraltar is not just a geographically significant body of water, it is a bustling maritime highway, essential for global trade and transportation. Thousands of vessels, from massive cargo ships to smaller fishing boats, navigate this narrow passage each year, carrying goods and people between the Mediterranean Sea and the Atlantic Ocean. The sheer volume of maritime traffic passing through the strait presents a significant challenge for any bridge construction. Imagine a constant flow of vehicles on a busy highway. Now envision building a structure over that highway without disrupting the flow of traffic. Constructing a bridge across the strait would necessitate careful planning and coordination to avoid disrupting this vital maritime route. The height and design of the bridge would be critical to ensure safe passage for ships, while also considering the impact on shipping schedules and costs. The Strait of Gibraltar's importance as a maritime route adds another layer of complexity to the already challenging prospect of bridge construction. Any proposed project would need to address the needs of the shipping industry and ensure minimal disruption to this crucial global trade route. The Strait of Gibraltar lies in a region of significant tectonic activity where the African and Eurasian plates meet. This ongoing collision, spanning millions of years, has shaped the region's dramatic landscape, including the formation of the strait itself. However, this tectonic activity also poses a significant challenge for large-scale infrastructure projects like a bridge. Earthquakes are a constant threat in this seismically active zone. A major earthquake could cause devastating damage to a bridge, potentially leading to collapse and significant loss of life. Designing a structure capable of withstanding the powerful forces unleashed by earthquakes in such an active area would be an immense engineering challenge. Furthermore, the movement of tectonic plates, while gradual, can lead to shifts in the seabed. These shifts over time could compromise the stability of bridge supports, potentially leading to structural damage and compromising the bridge's integrity. The ongoing tectonic activity in the Strait of Gibraltar region presents a significant risk for any bridge construction project. The constant threat of earthquakes and the potential for seabed shifts require engineers to develop innovative solutions to mitigate these geological risks and ensure long-term stability.